What's up, guys, and welcome to this video. Okay, so we're going to be covering acceleration. In the previous video we did instantaneous velocity and we spoke about the difference between speed and velocity. I just want to define instantaneous velocity because I didn't last time. But the definition for instantaneous velocity is the velocity of an object at a precise moment. Okay, so remember we said that it can be over a very small time interval, or if it is a very large time interval, then we use the average speed and a direction. Okay, so we also did an example, but now we're moving on to acceleration. Okay, so let's define acceleration and try to understand what it is. Okay, so acceleration, the definition for acceleration is the rate of change of velocity. Okay, and if you remember, velocity is a vector. Okay, so it's a vector quantity, and so our acceleration is also has to deal with a vector, so it is a vector as well. So acceleration can be positive or negative. It must have a magnitude and a direction associated with it. Okay, so what is acceleration? Okay, so acceleration is basically how fast the velocity of an object changes with time. So the acceleration is defined as our change in velocity over our change in time. Okay, and our units are going to be, so the units that we have here for velocity, it's meters per second divided by seconds, right? So we're left with meters per second squared, or we can write it like that as well. Okay, these are all the same thing. Okay, so our units for acceleration is meters per second squared. Okay, and obviously, like before, our change in velocity is just velocity final minus velocity initial over time final minus time initial. Okay, so acceleration doesn't provide much information about the motion, only how the motion is changing. So acceleration has to do with how the motion is changing. Okay, so we're not really able to tell how fast something's going, we only know how fast it is changing. Okay, so that's what we know, and we know that acceleration must be a vector, so it can be positive or negative. Okay, so the direction of the acceleration is always in the same direction as the force causing the acceleration. Okay, so we'll touch on that again, and also something to note that a positive acceleration doesn't necessarily mean that, so positive acceleration doesn't always mean that our velocity is increasing. Okay, and similarly, a negative acceleration doesn't necessarily, mean that the velocity is decreasing either. Okay, increasing or decreasing. Okay, so basically we need to understand how the acceleration and the forces are affecting the object. Okay, so let's go on and do some examples just to elaborate on these things. So I think this is example 3. Okay, so just to clarify here, what the most important things, the takeaways from this video is this equation right here, what the acceleration equation is, as well as the definition and the fact that it is a vector. Everything else should become more clear as we go on. Okay, so for this example, let's say we have a box, right? And we have a net force acting towards the left, F net. Okay, and we know that F net is equal to ma. So F net is what causes our acceleration. But our initial velocity initial, is to the right. Okay, so let's try and understand what's happening. So the initial velocity is to the right here, right? And so we're going to take the right hand side direction as being positive. So it is positive. Okay, the net force is acting leftwards. So it is so the left direction would be our negative direction. Okay, so the acceleration, therefore, okay, so the acceleration is negative, and what's going to happen? The object will slow down. Okay, so I hope that makes sense, guys. So let me try and make this a bit more clear. So we have a object that's moving. Let's actually put that in there. Okay, so we have an object that's moving towards the right direction initially, but the net force, so let's say it starts out fast, but the net force is acting towards the left, so it's slowing down this object. Eventually the object will stop, and then if this force continues, then the object's going to move in the leftwards direction and accelerate in that direction. So here's a case where we have a negative acceleration and the object is slowing down. Okay, so if we look at a different scenario, okay, all I'm going to do here is change the direction of some arrows. Okay, so we're going to make that to the left. Okay, so if we work with the same sentences I've got here, the initial velocity is to the, okay, if we look at this, okay, so we're looking at this example now, the initial velocity is to the left, so it is negative. Okay, so we have it being a negative velocity. The net force is acting to the left as well, so we have a negative, and the object will, okay, so it's moving leftwards and the net force is acting to the left, so the object will speed up. Okay, so to draw attention to what's happening here as well, so let's say we have an object starting over here, and initially it starts off quite slow, but then the net force is acting on it, so it's speeding up and it's going to get faster and faster and faster, and it's accelerating in that direction. Okay, let's see, how can we do one more example? Okay, so in that example that we had before, what we have is a negative velocity and a negative acceleration resulting in it speeding up. So here we're going to look at the opposite basically. So in this last example, what we have is our initial velocity is to the right and our net force is to the right as well. Okay, so then what we have to look at is all these things. Okay, so let's say the initial velocity is to the right. Okay, so that is positive. The net force is acting rightwards, and so this is also positive because I've defined the direction as being positive to the right. So the object will, okay, so what's happening here? The object will speed up. Okay, so once again, it will speed up. Okay, so if we draw attention to this bottom diagram, so we have an object somewhere here, and it's going at a normal speed, quite slow, but we have a net force acting on it, so it is speeding up and it is getting faster and faster. Okay, so I hope that makes sense. Okay, so I don't want to really touch on these graphs yet. I want to go over the displacement time graphs and the velocity time graphs, and then the acceleration time graphs. Okay, so I'm going to leave that for the next video. In this video, basically, I wanted to draw attention to what acceleration is, the units of acceleration, and just to this idea that a positive acceleration doesn't necessarily mean the velocity is always increasing, and a negative acceleration doesn't always mean that the velocity is decreasing. So if we look at this example, what we had is a positive acceleration, which resulted in a positive velocity, or the object speeding up. Okay, but in our first example, we had a different case. Okay, so cool stuff, guys. Yeah, that's all I want to do in this video. I think it's a relatively short video, just touching on some concepts. Okay, thanks for watching, guys. In the next video, we will be touching on graphs. Cool stuff.